In this video, I'd like to look at two more challenging problems for the explicit formulas for arithmetic sequences. So in this example, Philippe and Ling were asked to find an explicit formula for the sequence 24, 16, 8, and so on, where the first term should be f of 1. And before we look at their specific examples, let's just remind ourselves what the general formula is for an explicit formula for these arithmetic sequences. So a general formula, we could say f of n, where n is our nth term in the sequence, is equal to the first term of the sequence plus the common difference of this sequence multiplied by n minus 1. So d here, this is our common difference. And let's generate our own formula and then compare that to what Philippe and Ling have. So our sequence, f of n, is equal to the first term, so in our case that's 24, plus the common difference, and we're going to add that n minus 1 times. So our common difference, notice that from each step, from one term to the next, that we're always subtracting 8. And you can see that most clearly going from 8 to 0. So really we're adding negative 8, and we're going to add it n minus 1 times. Now you always add it 1 less than n, since you don't want to add the common difference to your first term. It's only from that term that you start adding or subtracting that common difference. So let's rewrite it without the adding a negative. So it's 24 minus 8 times n minus 1. Now, going back to their formulas, notice that neither of them are exactly what we have. And we can eliminate Ling's formula right away, since ours is 24 minus 8 times n minus 1, where this is 24 minus 8n. So it's missing the parentheses times n minus 1 there. And what we really should do, actually before comparing, is just check to make sure that our answer is correct. And you can check these by comparing it to one of the known terms of the sequence. For instance, we know that the fourth term of our sequence is equal to 0. So let's plug in n equals 4 here to see if we get 4 in our formula. And at least that way we can feel confident that this is in fact the correct formula. So we have 24 minus 8 times 4 minus 1, which is 24 minus 8 times 3, and 8 times 3 is 24. So we have 24 minus 24, which is 0. So our check worked, which means that we know for sure this formula we generated, this is correct. And so that way we now know for sure that Ling's formula is incorrect. So let's just check Philippe's. It does look different than ours, but Philippe is subtracting 8n rather than subtracting 8 times n minus 1. And sometimes with these formulas, it makes sense to distribute this common difference to the n minus 1 term. So let's do that and see if we can recreate Philippe's formula. So we have that our arithmetic sequence is equal to 24, and we're distributing the negative 8 to each of these, so we get minus 8n, and we get minus 8 times negative 1, which is plus 8. And now just combining like terms, we can rewrite this as 24 plus 8, which is 32, minus 8n. So this is another way to write our sequence here. And notice, this is exactly what Philippe has. So Philippe's formula is correct. And since Ling's is not correct, we can assume that choice A is the correct answer here. So let's do one more of these problems. And in this one, we're going to have Oliver and Putri, but we're still trying to find an explicit formula for a new sequence this time. So let's just first rewrite our general formula. That for this arithmetic sequence, we have h of n is equal to our first term plus some common difference times by n minus 1. So we just need to figure out what our first term is and what our common difference is. But notice from one term to the next, we are adding 17. So our common difference, that's 17. And our first term, that's minus 51. So if we generate our own sequence, or our own formula for the sequence, we can write this as the first term minus 51 plus this common difference 17 times by n minus 1. And let's just double check, make sure that this actually makes sense. So maybe this time let's check for the third term, since we know that when you look at the third term in this specific sequence, we should get minus 17. So let's plug 3 into our formula. So we get that n equals 3 in this formula. So h of 3 is minus 51 plus 17 multiplied by n minus 1, or 3 minus 1, which is 2. So we get minus 51, 17 times 2 is 34. And when you add these together, you do get minus 17, which is what we expected. So that just means we can feel confident that the formula we generated is in fact correct. Now, looking at Oliver and Putri's formulas, notice neither of them look exactly like ours. And we can actually eliminate Oliver's formula right away, since it doesn't have the plus 17 times n minus 1 like our formula. It has plus 17 times n. So that's definitely not correct. And Putri's formula, it's different than ours, but it could potentially be right if we distribute the 17 to each of these terms. So let's make a little space and try and simplify this. So distributing here, we have minus 51 plus 17n, and we have 17 times negative 1, which is minus 17. So combining like terms, minus 51 minus 17 would be minus 68 plus 17n. And this is just another way to rewrite our explicit formula here. But notice that Putri actually had that exact formula. So this is correct. And the answer here will be B. Now, one other way to approach these problems, besides finding the formula yourself, making sure it works, and then comparing it to both of their answers, the other way is to just plug in n values and see if you get back the sequence. For instance, in Oliver's formula, if we plug in n equals 1, we get minus 51 plus 17, which if you add these together is equal to minus 34. But this is supposed to be the first term, and we know the first term is minus 51. So that's one way to know that that's incorrect. Now for Putri's formula, we can do the same thing. We can plug in n equals 1 here. So h of 1 would be minus 68 plus 17, which is minus 51. So I got the first one right. If we check a second one in this formula, it'd be minus 68 plus 17 times 2 now, or plus 34. And when you add those together, you do get minus 34. So that's another way to check these answers, or just to approach the problem that way. And sometimes it's best to just approach the problem in two different ways, depending how certain you need to be about the final answer. So if you need to know for sure, if you're, for instance, looking at a problem like this on a test, then it might be worth doing it both ways if you have the time.